we're using. For this next method, we're going to want to update existing data in our database. And for this, we're going to use another cool entity framework feature. Now, what are we getting here? We're getting the ID of the record that we want to update, and we're getting a new version of it. So we're going to use that data to actually code this update. So first of all, I start by fetching a movie using the findAsync method as we have used above, and we're using that to fetch the existing movie from the database. But as you may remember, this can return NULL. So we're going to use we're going to check if this existing movie is NULL. And if so, we're going to have to return a 404.found. And the way to do that in ASP.NET is just to return not found. So from now on, we know that we have an existing movie and we're going to update it. So on this existing movie, I can just set the title to the new title, the one coming from the new version of our movie, the one that was posted to our API. And I can do that for all of the properties that we want to update. So I can also update the release date to the new release date, and I'm going to update the synopsis to the new synopsis. So once that is done, you are right to think that none of this is actually changing anything in the database, and you are right. So just like above, we could call the save changes on our DB context. Now you are right to think like we've updated an object, a movie object in our code, and how does the DB context know what it needs to do? Now the way that works is the same way that we've done it above. The DB context keeps track of all of the changes that it needs to persist into the database. Now, how does this work when this is just a movie object? Now, when you run this code and you inspect the type of existing movie, you will see that it is a proxy class that inherits from our movie model. And this is very important because this is a proxy, it actually keeps a connection to the DB context. And as soon as we start to do this, changing the values of the properties on the proxy, it will notify the DB context that there is a change on this entity that needs to be persisted. And as soon as we call the save changes, that will actually make sure that we perform an update on that record in our database. And that works because this is using something called the change tracker. Every DB context has a tracker for all of the changes that need to be persisted. And once we are done, we can just return an OK, a 200 with the new version of our existing movie. And this is how you code this update and how you leverage the change tracker to do updates of existing data in your database. For the last method in our controller, we're going to be removing data from our database. And as you can already guess from the attributes that you see here on the controller action, we're going to do something similar from above because we're going to need to return a 404 not found if we don't find the record that has this ID. So I'm shamelessly copy pasting it from the update method, where we fetch the existing movie and then return a not found if we don't have it. Now from here on out, we can actually remove it from the DB set and use that repository feature on it. So I can just go context.movies, which is our DB set, .remove, and pass in the existing movie object, and that will remove it from the database. So all there's left for us to do is call the save changes method because this remove has queued this remove to happen in the database as well. So context save changes async, and we will return obviously an OK. In this case, an empty one because the object no longer exists. But this is where we can do some different approaches. Because this is a tracked object and it is of the type movie, we don't actually need to do it on the movie's DB set. We could just as well do this on the context instead of on the DB set, because the context knows that it's a movie, it knows what table it is in, so there's no need to do it on the DB set. We could also do it on the context. Another cool thing that we could do, if we would not have this need for returning a not found above, we could actually save ourselves a round trip to the database by doing the exact same thing, but with a movie object that we're not getting from the DB context, and that is working just as well. So we could just create a new movie object with the relevant parameters, in our case the primary key, and this will be good enough for Entity Framework to figure out which record needs to be deleted. So you could comment all of this out, and you could still have this method work just as well, and on the save changes it will delete that record. A similar approach can be used with updates as well. Now I think that this one is the cleanest, so I'm gonna keep that one out of these three, but know that the other two work just as well for the future. So that's how you remove data from the database with Entity Framework. So now we've implemented all of these controller actions, let's move a little bit deeper on what other stuff you need to know about Entity Framework. Now let's take a look at how Entity Framework queries get executed. Let's say that we are tasked with implementing this method. We're gonna have to fetch all of the movies by year. So we have to return a list of movies for an integer that represents the year that they were released in. Now, logically, what needs to happen can be written out like this. Let's define all of our movies as all of the movies in our database. So we are going to get the entire DB set from our DB context. Then for all of those movies, we're only interested in a portion. So we're gonna define that filtered list as such. Filtered movies. And that is going to be all of our movies, but with a where clause applied. And we're only interested in those movies that have a release date that has a year component that matches the year that we're looking for. So this predicate defines a link query, and I'll get back to what that is in a second. This defines a link query that filters all of our movies. All there's left for us to do now is return the results to the user. So we're going to return a 200 OK result. And what we're going to do is we're going to do wait for the filtered movies.toListAsync. That's it. So logically, this is what this function does. But at first sight, if you're not familiar with Link or Entity Framework, this looks horribly inefficient, because it looks as if we're fetching all of our movies from the database and pulling them into memory, and then only filtering them here, and then we're returning them to the user, which means that this round trip could be way too big for what we need, and especially as this table grows, this could be a performance bottleneck. Now, luckily, that is not what happened, because Link is the collection of extension methods that define a query language inside of C#, and this where clause is part of what Link does. And all of those extension methods are written against certain interfaces, and it'll become a lot more clear what is happening if I redefine these two vars right here. So this is a DB set, but DB set has a crucial interface to make all of this work, which is iQueryable. And iQueryable has a generic type parameter of the type of object that is going to be in there. So this is a queryable list of movies, but by defining the filtered movies, that is exactly the same. This is also an iQueryable. And in Link, there is a concept called deferred execution, which means that a Link query only executes whether it targets iQueryable or IEnumerable. It only executes when you actually ask for results. So when you do a first or default, or you do a toList or toArray, or you iterate over the results of the query, those are things that actually trigger the query to execute. But defining a query does not. So all that this line does is defining a query that represents all of the movies, but it is not executed. This line defines a subset. It puts a where clause on top of this queryable right here, and that adds the filter on top of it, but again, it is not executed. It is only when we call the toList async right here that we will trigger a database query. And that's exactly what happens with iQueryable, and that is the difference between IEnumerable and iQueryable. Both of those interfaces can be used to run LINQ queries against, but everything that is IEnumerable, those are lists that we can iterate over. So anything IEnumerable, let's say a list or an array or a collection that we have in memory, that we can iterate over, that's all going to run in memory and it's all going to run as for eaches. Now anything that implements iQueryable behaves completely differently. All of the queries get translated into the underlying query technology. So in our case, we are using SQL Server. Our where clause will get translated into an actual where clause on the database side. So when this toList executes, it will translate this where into an actual where clause when we are selecting data from this table. And that is exactly what we would want to happen if we are executing this query by hand and if we are writing our SQL by hand. So even although this looked horribly inefficient like this, actually the execution is anything but. Now LINQ has two different syntaxes, and I usually prefer the Lambda syntax. In most cases, I actually think that it looks cleaner, because usually I would write this query like this. Without the filtered movies, I would remove and append the where clauses line after line on the same thing. Let's say that we make our filtered movies like this. We can basically just add this where clause on the next line, and we have something that looks really clean and is really maintainable. And if you have multiple where clauses and maybe projections or whatever, don't worry, we will learn about all of those things in the next couple of chapters. If we have multiple things going on, it adds up really nicely, it's clean to read. But there is a different syntax. It's a syntax that was made for people who are familiar with SQL. It is called the query syntax, and I'm just going to copy paste it in now. Because it does exactly the same. It just looks different. So what Microsoft did when they devised what LINQ could do is they basically made a dialect of what SQL looks like to query things that are iQueryable or IEnumerable as well. The only thing they got right in this that was really a lot better than SQL is that you first define what you're querying from. And for all of the rest that you're going to type afterwards, you're going to actually have IntelliSense. In SQL, that is horrible because you do select and then you have to list a field list, and then you don't even, then only then you type the table that you're actually selecting from, which is a horrible order to do things in. So they flipped that around for this query syntax in LINQ, which is actually really nice. And this does exactly the same thing as before, but it just looks different. So from a movie, and this is just an alias that I'm giving to the type of object that is in here, I'm going to take all of my movies and I'm going to say where my release date year equals year. I'm going to select the entire movie. Now this syntax does exactly the same as the one above. It's just two different ways of writing LINQ. Now, when I was a young developer, I actually preferred this syntax a lot, but I've moved away from that and used this one more. I only grab this one when I have to do very complex group bys and joins. Then this one becomes more clear in certain cases. Most of the time, you're going to see me using that one. Now, this executes and it works just as well, and this will translate into a very nice where clause on the database side.